The spectrochemical analysis is basically used in industries, medicine, and in crime detection. Now, the next thing is to understand the concept of absorption spectrum. Now, when a composite light is made to pass through a semi-transparent substance, say a cold gas, you can see a spectrum over here. The spectrum what you get will have dark lines. Now, so the transmitted light, so the light what you see over here, it lacks particular colors or bands. Now these bands represent that some of the colors were absorbed by this cold gas or a semi-transparent substance. So those colors will not be present in the continuous spectrum. Instead of that, since the colors are absorbed, those particular colors will be represented in the form of a dark line or bands. It is more clear with this diagram. You can see it over here. It's a composite light. It is made to pass through a cold gas in this case. Then it is made to pass through a prism. You can see a continuous spectrum. This is an example. This is a continuous spectrum. Because the cold gas has absorbed some particular colors, those colors will not be present in the continuous spectrum. Instead, those absorbed colors are represented in the form of a dark lines or bands. Now, this kind of spectrum is called as an absorption spectrum. When a white light from a carbon arc lamp is made to pass through sodium vapor, then the continuous spectrum will have two dark lines in the yellow region. Now this shows the yellow, those lines were absorbed because of the sodium gas. Now let us go on to understand the concept of Fraunhofer lines. Now the solar spectrum also has got lot of dark lines. Now these are called as the dark lines are called as Fraunhofer lines. Now these lines are caused because some of the colors were absorbed by the elements in the atmosphere. Now these dark lines are nothing but some particular colors were absorbed by the elements present in the atmosphere. So the study of Fraunhofer lines has enabled us to identify the presence of those elements in the atmosphere. So that is how you can understand the concept of Fraunhofer lines, Raman effect or CV Raman effect. Now before that we have to understand certain points over there. Now a normal light wave or any composite light will have multiple wavelengths. You can see the light is not in this light is divergent. Light is divergent, it is not parallel, it is dispersed. It is dispersed, that is multidirectional. The light rays coming out of this filament is in multiple directions. So this is called as normal light wave. Whereas in case of laser waves, we got to understand that the light that comes out of the laser is monochromatic. That is, it has got a same wavelength in a very narrow range. Second thing is they are collimated, that is they are parallel and not diverging. And third thing is they are coherent, that is unidirectional. Now scientists Rayleigh and Tyndall, they discovered that when a ray of light was allowed to pass through a homogeneous and transparent medium, for example assuming this is as an homogeneous and transparent medium, a portion of the light it got deflected sideways or scattered. You can see that some of the lights, for example this one and this one, they got deflected and they got scattered. Now the wavelength, for example the wavelength of these scattered, for example the wavelength of these scattered lines were same as that of the incident light. Now Rayleigh went on to study about the concept as to why the sky looks blue. So he made a proper explanation of the blue color of the sky on the basis of the scattering of the light, okay, by the molecules in the atmosphere. Now you can see the blue color refracts more than the red light because of the difference in the wavelength. Now this causes blue light to deviate from its original path by a greater angle than the red light. We know that red has got a higher wavelength compared to a blue color. Now the sky is blue basically because of the scattering of the light by the molecules in the atmosphere. The intensity of the scattered light is inversely proportional to the wavelength. As the wavelength reduces, the intensity of the scattered light decreases. Now we have seen that blue color has got a lesser wavelength compared to red wavelength. So hence the sky appears blue when sunlight passes through the atmosphere. Blue color is scattered most, and that is why it looks blue. Similarly, when at the sunset and the sunrise, sunlight passes through a maximum length of atmosphere. Therefore, much of the blue is taken away by scattering. The light that reaches the Earth's surface lacks in blue color because most sunlight is passed through the atmosphere, and that is why you can see sunlight and the sunrise, they appear reddish. Rayleigh also found out that the intensity of the scattered light in a medium is inversely proportional to the fourth power of the wavelength, and this kind of scattering is called as Rayleigh scattering. You can see it over here. And Rayleigh scattering, it's also called as coherent scattering because the wavelength will remain the same. Now, in 1928, C.V. Raman studied these things. He found out that when a monochromatic light, you can see it over here, is passed through organic liquids like you can say either benzene or toluene, the scattered light was no longer monochromatic. The Rayleigh scattering over here, the scattered light is no more monochromatic. The scattered light also contains, for example, this portion, the scattered light, they contained both the scattered light contained both higher and lower frequencies along with frequencies in addition to that of the incident light. This phenomena is called as the Raman effect. Because of this discovery, C.V. Raman was awarded with the Nobel Prize in 1930. Now, special spectroscopes are actually required to observe the Raman effect. Now, for this reason, Raman scattering is called as an incoherent scattering, and this is basically used in the study of a great number of liquids, vapors, gases, and some solids. It is very useful to understand the structure of molecules that constitute matter. So this completes the concept of light. Thank you.